Today we're going to look at the last 10 or so slides from the hedging with options notes that we did not cover in class yesterday. When hedging a portfolio, rather than a single stock, we must use index options, that is, call options or put options written on a stock market index such as the S&P 500. Often, the stocks in our portfolio do not exactly match those in the index. Because of this, we have to make an adjustment to the hedge ratio equation. The equation is the hedge ratio is equal to the dollar value of your portfolio divided by what's called the option contract value. That's calculated as the exercise price on your option times the multiplier. For most index options, the multiplier is 100. It's as if we were buying an option on 100 shares of the index. Next, we'll multiply by the portfolio beta, and finally by 1 over delta. This beta is calculated by regressing the portfolio returns on the stock index returns. We'll have a look on the next page, and I'll show you how we estimate that beta. I collected daily data for 1 year on the S&P 500 index, along with the dollar value of the Student Managed Investment Fund Traditional Equity Portfolio. We only see 7 days here, but there are a full year in my data set. Next, for each day, I calculate the return on the index. I take today's index value, divide it by yesterday's index value, and subtract 1. Then I calculate the return on the SMIF portfolio each day. I take the value of SMIF today, divide it by the value yesterday, and subtract 1. Next, I plot the S&P 500 returns on the x-axis and the SMIF returns on the y-axis of my chart, as we see up here. And then I have Excel fit a trend line through the data points. Here's our regression equation, y equals 0.9514x minus 0.0001. This variable here is the beta for our stock. So over this 1 year time period, the student portfolio had a beta of about 0.95. Let's look at an example of hedging with index options. Suppose you're managing a large cap stock portfolio worth $2 million on the 31st of October 2016. You want to hedge against a possible market decline following the upcoming presidential election. Your portfolio has a beta of 1.2. Now, this is not the beta that we calculated a minute ago. That was just for our student managed investment fund, and this is a different example. So this is a different beta. So this portfolio has a beta of 1.2 relative to the S&P 500 index. The standard deviation of returns on the index I estimated at 14% using historical data. On October 31st, the S&P 500 index was at 2126.53. There's a call option available on the index. It has an exercise price of $21.25, so it's almost at the money. This option expires on December 16th, which is 46 days out. I've converted that into a decimal number of years. This option has a multiplier of 100. It is a European option, cannot be exercised before the expiration date. And this option was selling for $43.31. We'll calculate the hedge ratio. We take the dollar value of our portfolio, $2 million, and divide that by what's known as the contract value for the option. We take the exercise price on the option, $21.25, and multiply that by the multiplier on that index option. It has a multiplier of 100. Next, we multiply by our portfolio beta, 1.2. And finally, we multiply by 1 divided by delta for the option. The delta is 0.5187, and that was calculated using the Black-Scholes option pricing model. I put in the index value, the option exercise price, timed expiration, risk-free rate, and standard deviation. That gave me a delta of 0.5187. Doing the math, we see that we need 21.7 option contracts. We'll round that up to 22 contracts. We are going to write call options to create our hedge. Now we're at expiration, and the index has closed at 1900. The portfolio value has also fallen to 1,800,000. So the profit on our portfolio is the ending value, 1,800,000, minus the beginning value, 2 million. So we lost $200,000 on the stock portfolio during this hedging period. At expiration, the value of a call option is its intrinsic value at expiration plus the time value at expiration. However, there is no time value at expiration. The option has expired, and so the only value an option has at expiration is its intrinsic value. That intrinsic value is the maximum of 0 or the ending index level minus the exercise price. So we can calculate our options profit as follows. It's the number of contracts we have, 22 contracts, times the ending value. We'll use that intrinsic value as we saw up here. It's the maximum of 0 or the index level of 1900 minus the exercise price of 21.25. We subtract the initial premium on the call option, which was 43.31. And finally, we multiply it by 100, which is the multiplier on the index option. This gives us a profit of 95,282 on the index options, and we can calculate our total profit as the loss on our stock portfolio, 200,000, plus the gain on the index options, 95,282, and that gives us a net loss of $104,718. The hedge worked a little bit. It's better than losing 200,000, which would be our unhedged profit, but still we had a substantial loss. So our total profit was about minus 104,000. Why did the call hedge work so poorly? As the stock market fell, the delta for our call options decreased, and so the hedge ratio, which is 1 over the delta, will increase. Let's look down here. At high stock prices, our hedge ratio is near 1. As the stock price falls, the hedge ratio increases to 2 and eventually approaches infinity. So that's the problem we had here. As stock prices fell, our hedge ratio increased, but we maintained a static hedge and did not write more call options. Now let's have a look at hedging using put options. There's a put option available on the S&P 500 index with the same terms as the call we used previously. This put option has a premium of $40.98. We'll calculate our hedge ratio as the portfolio value, which is $2 million. We'll divide that by the exercise price on the call, the exercise price on the put, times the multiplier of the put. Next, we'll multiply by the beta of our portfolio, and finally by 1 over the absolute value of the put delta. The put delta is simply the call delta minus 1. The horizontal or vertical bars indicate we're taking the absolute value. Doing the math, we'll see we need 23.4 contracts, and we'll round that up, or round that to 23 contracts. Note that in this case, we will be buying put options to create a hedge. At expiration, the index has fallen to 1900, the same assumption we made using the call option hedge. And our portfolio is also at $1.8 million. We'll calculate our profit on the portfolio. We'll take the ending value minus the beginning value. Again, we lose $200,000 on the portfolio. To get our option profits, we'll take the number of contracts we purchased, 23. At expiration, the put option has no time value, only intrinsic value. So we'll take the intrinsic value at expiration. It's the maximum of 0 or the exercise price on the option minus the index level. Next, we'll subtract the premium we paid to buy the put option, $40.98. And lastly, we'll multiply by the multiplier on that index option, 100. This gives us a profit on the puts of $423,246. So to get our total profit, we'll take the loss on our stocks, $200,000. We'll add the profit on our put options, $423,246. And that gives us a total profit of $223,246. Notice that we have a positive profit when we use put options to hedge. When we use call options, we had a negative profit. So again, the profit on our hedge was the loss on our stock portfolio plus the gain on the index options give us a net profit positive 223,246. Why did the puts work so well when the call options work so poorly? The answer, of course, is the options delta. As the stock market falls, delta for put options increases, and so the hedge ratio, which is 1 over delta, will decrease. Let's have a look down here. So initially, we're using at-the-money options, so we had a hedge ratio about 2. In this case, because we were using index options, we had to modify that hedge ratio. In any event, as the value of the stocks fall, the hedge ratio decreases. However, we maintained a static hedge ratio, and so we end up being substantially overhedged as the stock price falls, or as the value of our stock portfolio falls. This concludes our discussion of hedging with options.